They told us the pyramids were tombs, monuments to dead kings and vanished dynasties. But what if that story is wrong? What if these colossal structures are not the beginning of civilization, but its last surviving memory? Across the sands of Egypt, beneath the unrelenting sun, rises a geometry so precise it defies time. A line to the stars, built from millions of tons of stone, and older perhaps than the very desert that surrounds it. New geological evidence suggests rain once carved the body of the Sphinx. Astronomical data points to alignments that fit not 4,500 years ago, but 12,000. And that number matters, because 12,000 years ago, the world nearly ended. The Younger Dryas cataclysm, a sudden global collapse, turned forests to deserts and oceans into graves. Yet the pyramids still stand, silent, perfect, and impossible. So we must ask the question no textbook dares to pose. Were the builders of Giza survivors of that lost world, a civilization erased by fire and flood? Tonight we return to the desert that remembers, to decode the stones, the stars, and the silence they left behind. Satellite data from NASA's Shuttle Radar Topography mission reveals vast buried riverbeds, paleochannels, meandering beneath the Sahara's sands. One of them, the Tamanrasset River, once crossed the heart of North Africa, forming a delta the size of modern Egypt. Another, the recently discovered Ahramat Branch, flowed near the Giza Plateau itself. The name means pyramids in Arabic, fitting, for it may have lapped at the feet of the monuments we see today. 12,000 years ago, this region was not desert but grassland, a green corridor stretching from the Red Sea to Libya. Pollen samples from the Fayum Depression and fossilized remains of hippos and crocodiles in the western desert prove the Sahara once teemed with life. Geologists call this era the African humid period, when the monsoon belt shifted north, turning the Sahara into an oasis of lakes and rivers. Cave art from Gilf Kibir and Tassili Naja captures this lost world. Giraffes, hunters, and reed boats gliding across waters that no longer exist. Then came catastrophe. Around 12,900 years ago, at the dawn of the Younger Dryas, the rains stopped. Temperatures plunged, ice returned, and the monsoon collapsed. Within generations, lakes became salt pans, rivers turned to dust, and the green Sahara died. Those who lived there migrated east, following the last lifeline of water, the Nile. If monumental architecture existed before this collapse, most of it would have vanished. Only structures carved into bedrock or built on high, stable ground could endure. The Sphinx and the Great Pyramid, their cores fused to limestone foundation, might be survivors of that earlier age, carried through the millennia by the same desiccation that erased everything else. Drilling beneath the Giza Plateau reveals alternating layers of ancient soil, from river sediments to desiccated clay, silent records of a changing world. Within these layers, scientists find freshwater diatoms, microscopic algae that grow only in standing water. They prove that this land, now among the driest on Earth, once held pools and streams. Even the limestone of Giza bears vertical erosion flutes, carved not by wind but by centuries of rainfall. Some geologists propose that this wetter window, between 12,000 and 8,000 BCE, could have been the true age of the plateau's earliest construction, a time of recovery when the ice receded and rivers briefly returned. The horizon would have been clear then, the climate stable, the Nile overflowing with life, conditions ideal for monumental engineering and precise astronomical alignment. Ancient inscriptions echo this forgotten climate. Carvings at Wadi Hammamat speak of flowing streams. Others near Karga Oasis depict gazelles and long-extinct wild cattle. And far to the southwest at Nabta Playa, a stone circle older than Stonehenge tracks the summer solstice sunrise. Its builders, cattle herders living by seasonal lakes, were already studying the heavens. When their land turned to desert, they moved toward the Nile, carrying their star knowledge with them. Perhaps they were the ancestors of those who would one day measure Giza's alignment to the sky. Imagine that moment of change, rivers fading, forests turning to dust, and a people realizing their world was ending. They may have built not from ambition, but from memory, monuments meant to outlast the storm. The first stones may have been raised as an act of remembrance, a record in limestone of a world drowned by time. Paradoxically, it was the desert that preserved that record. The same dryness that kills life has kept the past intact. In archaeology, this is called the paradox of preservation, the truth that desolation protects. Papyrus mummies and granite alike have endured because the rains never returned. Egypt's past did not vanish, it was embalmed in sand. When you stand at Giza today, beneath the morning sun, you are not witnessing civilization's triumph over nature, but the residue of nature's retreat. The pyramids are geological fossils of human will, memories of a greener earth carved in the age when the Sahara still breathed. Science now confirms what myth long implied. Egypt was born not in isolation, but in a cycle. Creation, destruction, renewal. Its roots reach back into the rhythms of the planet itself. The desert is not emptiness, but archive. Every dune holds data. Isotopes, pollen, fossil dust, whispers of the worlds that came before. And so the story begins not with what was built, but with what was lost. Before we can ask who raised the pyramids, we must first ask what kind of world could give birth to them, and what kind of catastrophe could erase it so completely. The sun climbs higher, and with it, the light sharpens against the face of the great Sphinx. Every tourist sees the same figure, the human head, the lion's body, the colossal stillness watching east toward the rising sun. But look closer at what surrounds it. The trench in which the Sphinx lies half buried. These walls, carved straight from the bedrock, are the Sphinx's oldest secret. Run your hand, if you could, along the inner enclosure. The rock is scalloped, wave-shaped, flowing like frozen water. The channels run vertically, not horizontally, as if torrents once cascaded down the walls for centuries. These are not wind-carved lines. They are the footprints of rainfall, heavy, sustained, and impossible under Egypt's current climate. When Dr. Robert M. Schoch, a geologist from Boston University, first examined these features in 1991, he approached them not as an Egyptologist but as a scientist of stone. He noted that the most deeply weathered layers occur in the oldest strata of the Mokattam Formation, which underlies the Sphinx and the Giza Plateau. This limestone is relatively soft, easily carved by water but resistant to wind. Schoch compared its patterns to similar rain-sculpted formations along the Nile Valley and in the eastern Sahara, and the results were startling. To produce such deep, rounded channels, the area would have required hundreds of years of periodic heavy rainfall, conditions that have not existed in Egypt for at least 7,000 years, and more likely 10,000 or 12,000. In contrast, the accepted archaeological date for the Sphinx is around 2500 BCE, during the reign of Pharaoh Khafre, when the Sahara was already a hyper-arid desert, receiving barely a few millimeters of rain per year. The mismatch between geology and chronology was too great to ignore. Schoch's conclusion, published in the Geological Society of America Proceedings 1992, was radical but methodical. The core of the Sphinx must predate the Old Kingdom by thousands of years, potentially to the pre-Younger Dryas or early Holocene epoch, when Egypt experienced a wetter climate. This made the Sphinx not 4,500, but perhaps 9,000 to 12,000 years old. If the Sphinx truly carries scars of an age of rain, what does that say about the story of civilization itself? Drop your thoughts in the comments. Do you think it's just erosion, or the last geological proof of a forgotten world? Egyptologists responded with outrage. Their counterargument hinged on cultural logic. The Sphinx's face resembles Khafra's. Its temple complex uses blocks quarried from the same pit, and no texts mention the Sphinx before his reign. Therefore, they said, it must belong to him. But this reasoning assumes that Khafra built it, not restored it. The inventory stele, discovered in the 19th century at Saqqara, records Khufu visiting the House of Isis, mistress of the pyramids, near a statue of a great lion, implying the monument already existed before either pharaoh's time. Scholars often dismiss the stele as later mythology, yet its wording fits the geological picture perfectly. The Sphinx itself complicates things further. Its head is disproportionately small compared to its body, a feature inconsistent with Egyptian symmetry and proportions. Many researchers, including Egyptologist R.A. Shvala de Lubitsch, have suggested the current human face may be a later recarving of an older head, possibly leonine. If true, the Sphinx may once have been purely a lion, a fitting symbol for an era when the constellation Leo rose directly on the eastern horizon around 10,500 BCE, precisely where the Sphinx looks. The coincidence of celestial alignment and geological dating has drawn the attention of both astronomers and archaeologists, who suspect a link between sky and stone. Beyond stylistic debate, the physical evidence deepens. The Sphinx's body is carved directly from bedrock, but the stones used to build the adjacent Sphinx temple, weighing up to 200 tons each, were quarried from the same trench. These blocks, exposed to the same environment, show less erosion than the walls left behind, suggesting they were removed after the deepest weathering had already occurred. In other words, the enclosure was already ancient when the temple was built. Geological surveys by Egyptian and international teams in the 1990s confirmed that the deepest erosion occurs on the western and southern walls, exactly where ancient rainfall would have poured down from higher ground. The northern and eastern walls, partly shielded by the Sphinx's body and later constructions, show much shallower weathering. This pattern cannot be explained by wind. It is the geometry of storms. To visualize this, climatologists reconstructed the regional hydrology using isotope data from Nile Delta sediments and Lake Chad cores. These show a clear period of sustained heavy rainfall between 12,000 and 8,000 years ago, the same epoch during which Shock is dating places the Sphinx. The African monsoon belt had shifted northward, drenching what is now the Sahara. Even the White Nile carried more water then, forming vast floodplains across northern Sudan. This wetter world was not only plausible, but documented. Archaeological sites like Nabta Playa, in the far south of Egypt, show ceremonial structures built around seasonal lakes during precisely this time. The builders aligned their stones with solstices and star risings, much as later Egyptians would align their temples. The implication is that astronomical awareness and stone engineering existed here millennia before the pharaohs, suggesting continuity, not coincidence. If the Sphinx originated in that earlier age, then Khafra's builders may have found it half buried in sand, its face eroded beyond recognition. The restoration texts from the New Kingdom, more than 1,000 years after Khafre, describe the Sphinx as already ancient and covered in sand to its neck, pre-10. Pharaoh Thutmose IV famously dreamed of the statue pleading to be freed from the desert. He excavated it and left the dream stele between its paws. Even then, in 1400 BCE, the Sphinx was considered a relic from a forgotten past. For mainstream archaeology, this interpretation remains uncomfortable. Accepting that the Sphinx predates Egyptian civilization by millennia would require rewriting the foundation of world history, admitting that advanced builders existed before agriculture, writing, or organized states. But geology is indifferent to cultural pride. The stone bears only the marks of what it endured. The question then becomes, what world carved those marks? To the people of the wetter Sahara, the Sphinx would not have stood in a barren wasteland, but beside grasslands and riverbanks, facing a sunrise over fertile plains. Its lion body may have symbolized power, not over death, but over life. The guardian of rebirth in an age when rain brought everything back to life. Today, the enclosure is dry again. The same wind that once carried rain now scours the stone with sand. Yet beneath its weathered face, the Sphinx still carries the memory of water, the fingerprint of a climate that no human has seen for 12,000 years. If the Sphinx bears marks of a wetter world, and that world ended over 12,000 years ago, then what does that make the Sphinx itself? And who then were its true creators? When night descends over the Giza plateau, the desert transforms into a mirror of the sky. The air cools, the wind falls silent, and the pyramids rise from the earth like constellations turned to stone. For the ancient world, the heavens were not distant, they were destiny. The sky told time, marked harvests, and recorded the movements of gods. And nowhere on earth is that marriage between sky and stone more visible than here. The three great pyramids, Khufu, Khafre, and Menkaure, appear at first glance to form a simple diagonal line. Yet that line is imperfect. Menkaure's pyramid sits slightly offset, just east of the axis formed by the other two. To modern eyes, it looks like a construction error, a minor deviation. But in the early 1990s, engineer and researcher Robert Bauval looked not down but up, and saw that the three stars of Orion's belt, Alnitak, Alnilam, and Mintaka, form the same asymmetrical pattern in the night sky. When the layout of the pyramids is overlaid upon Orion's belt, the match is astonishing. The spacing corresponds not only in relative position, but in relative brightness. Khufu's pyramid, the largest, aligns with Alnitak, the brightest star. Khafre's with Alnilam, and Menkaure's smaller pyramid with the faint Mintaka. Even the offset is identical. The pyramids, it seems, were not placed at random, but as a terrestrial reflection of a celestial pattern, an idea later known as the Orion correlation theory. But Bauval's insight went further. He asked, when was this pattern most accurate? Because the Earth's axis slowly wobbles, a phenomenon known as axial precession, the stars' apparent positions shift over millennia. Using astronomical simulation software, Bauval rewound the sky thousands of years into the past. The result was a revelation. The alignment between Orion's belt and the Giza pyramids became perfect around 10,500 BCE, an epoch coinciding with the end of the Younger Dryas, the same era when the Sphinx's erosion suggests heavy rainfall and when the Sahara was still green. This date is not arbitrary. Around 10,500 BCE, the constellation Leo, the celestial lion, rose exactly on the eastern horizon at dawn during the spring equinox. The Sphinx, carved with the body of a lion and gazing due east, would have greeted the rising sun and the rising lion in perfect symmetry. The Sphinx looks at Leo, the pyramids mirror Orion. The two constellations are mythologically linked, Orion as Osiris, god of rebirth, and Leo as the solar guardian, day and night, death and resurrection. The alignment of the entire Giza complex thus becomes not just architectural, but cosmological, a map of heaven encoded in stone to symbolize eternal renewal. Critics argue coincidence, that any 3 points could match some stars. Yet statistical models tell a different story. Astronomer Dr. Virginia Trimble, reviewing Bauval's work, calculated that the chance of 3 pyramids matching 3 stars in both spacing and brightness purely by accident is less than 1 in 1,000. And the orientation to true north, accurate within 3 arc minutes, is so precise that it rivals modern laser-guided surveys. For context, the Great Pyramid deviates from true north by only 3 to 60ths of 1 degree, while the 19th century Paris Observatory is off by nearly 10 times that. How could ancient builders achieve such precision without compasses or telescopes? The answer lies in the stars themselves. The Egyptians used a method called stellar transit observation, tracking the crossing of circumpolar stars, those that never set, around the celestial pole. By marking where these stars crossed the meridian, they could determine true north with remarkable accuracy. Recent studies by physicist Kate Spence propose that the alignment of the pyramids corresponds precisely to when the stars Mizar and Kochab in Ursa Major and Ursa Minor formed a vertical line, an event that occurred around 2470 BCE near Khufu's supposed reign. Yet even this conventional explanation admits an extraordinary fact. The builders possessed millennia of astronomical observation data. To refine alignments to minutes of arc requires generations of tracking. Such knowledge implies continuity, a science inherited, not invented. The precision of Giza's plan extends beyond alignment. When viewed from above, the distances between the three pyramids reflect the angular spacing of Orion's belt as seen from Earth. The scale of the complex also encodes subtle mathematical constants. The ratio of the Great Pyramid's base to its height equals 2p, suggesting awareness of the relationship between a circle's circumference and diameter, a concept formalized only in classical Greece millennia later. Whether this was intentional or coincidental remains debated, but its recurrence in multiple Old Kingdom structures hints at deliberate design. This cosmic architecture continues within. The narrow air shafts of the Great Pyramid, long assumed to ventilate burial chambers, align precisely with specific stars. During the pyramid's construction era, one shaft pointed toward Orion's belt, another toward Sirius, the brightest star associated with the goddess Isis. The northern shafts aligned with Thuban and Kochab, symbols of immortality. The entire internal geometry seems tuned to the heavens, a stellar map inscribed into limestone corridors. For the Egyptians, these were not coincidences of faith and engineering, they were faith through engineering. The soul of the pharaoh, upon death, was said to ascend to the sky, to become one with Osiris in Orion and sail the eternal river of stars. The pyramid, then, was a literal stairway to the afterlife, a machine of ascension, geometrically aligned to channel the king's essence toward the cosmic gate. And yet, the alignment's greater mystery might not lie in religion, but in remembrance. What if the builders were not encoding only theology, but chronology? By fixing their monuments to the configuration of the sky in 10,500 BCE, they could have been marking a specific moment in deep time, a celestial timestamp. Unlike languages or calendars, the stars move predictably over millennia. Any future civilization capable of astronomical calculation could look up, compare the positions, and determine when the alignment was intended. It would be a message across ages. This is when we were. If that hypothesis holds, the pyramids are not simply tombs, but time capsules, monuments to survival after catastrophe, built by people who wanted to anchor their story to something eternal, the heavens. Mainstream science may resist this, preferring a later date and simpler motive, but even under conservative interpretations, Giza remains a marvel of observational astronomy. The builders recorded not just geography, but cosmology, a worldview that united Earth, sky, and the afterlife into one system. No other ancient culture achieved such perfect synthesis of architecture and astronomy. The next question, however, is not only who built Giza, but why. If the alignment was a message, what purpose did the pyramids themselves serve beyond symbolism? Geometry alone cannot explain their engineering. The staggering precision, the impossible weight, the materials chosen with surgical care. To understand that, we must step inside the stones themselves. Step inside the Great Pyramid, and the noise of the outside world dissolves into a dense, uncanny stillness. The air is cool and dry. Every sound, a footstep, a whisper, echoes upward through the steep limestone corridor known as the Grand Gallery, its walls rising in perfect corbelled layers. For thousands of years, this place has been called a tomb. But what kind of tomb is carved with such mathematical precision that its floor is level to within less than a single inch across 13 acres? What kind of tomb aligns to true north with an error smaller than 3 arc minutes? A precision we achieved again only with modern instruments. To call the Great Pyramid merely a grave for Pharaoh Khufu circa 2560 BCE feels almost reductive. There is no body, no funerary goods, no inscriptions naming Khufu as its occupant. The granite coffer in the so-called King's Chamber stands empty. Archaeologists have searched every inch for hieroglyphs. Nothing. It is a monument without signature, as if it was built not for a man, but for a principle. The deeper we look, the stranger it becomes. The Great Pyramid's structure is layered with materials of strikingly different physical properties. The core blocks are made of local Giza limestone, dense, stable, easily quarried, but the outer casing stones, now mostly gone, were made of Tura limestone, almost pure calcium carbonate. This material is a superb electrical insulator, highly reflective, and once polished to a mirror-like sheen. In sunlight, the pyramid would have gleamed white gold, visible from miles away, its surface capable of reflecting intense solar radiation. Inside, however, the builders used Aswan granite, transported from quarries over 800 kilometers to the south. This granite is composed of about 85% quartz crystal, 13% feldspar, and trace minerals that respond to stress through the piezoelectric effect, the same principle used in modern quartz watches and sensors. When compressed or vibrated, quartz generates a small electrical charge. Why would the builders combine an insulating outer shell with a conductive piezoelectric inner core? The configuration resembles a capacitor, a system designed to store or manage energy. This observation led engineer Christopher Dunn to propose one of the most provocative theories in modern archaeoengineering, that the Great Pyramid might have been designed to function as a resonant energy device, a monument that harnessed and amplified the Earth's natural vibrations. According to Dunn's model, the process begins far below the pyramid, in the subterranean chamber, carved deep into the bedrock. Beneath Giza runs an aquifer connected to the Nile's ancient course. Flowing water creates low-frequency sound waves, vibrations that travel through the limestone plateau. These vibrations could have been channeled upward through the pyramid's internal passages, which act as acoustic waveguides, much like the tune chambers of a musical instrument. Meanwhile, chemical residues found in the Queen's chamber shafts suggest something extraordinary. When British chemist Joseph Davidovits and later American engineers analysed samples from these tunnels, they detected traces of hydrated zinc chloride, ammonium chloride, and hydrochloric acid, compounds that, when combined, can produce hydrogen gas. If the shafts once contained these chemicals in liquid form, they could have acted as a primitive hydrogen generator, releasing vast quantities of hydrogen that filled the inner chambers. Hydrogen is highly reactive, and it also responds strongly to sound. When compressed or excited by resonance, it can amplify vibration and conduct electrical energy. Dunn theorized that as the Earth's natural tremors passed through the limestone foundation, they set the granite chambers vibrating. The piezoelectric quartz within the granite would then generate an electric field. The pyramid's unique geometry, with its conductive core, insulating casing, and possibly metallic capstone, could have allowed it to function as a gigantic harmonic resonator, capturing and concentrating energy, then releasing it into the atmosphere. Modern science offers intriguing parallels. In 2018, researchers from Russia's ITMO University and Germany's Laserzentrum Hanover published a study in the Journal of Applied Physics showing that the Great Pyramid exhibits measurable electromagnetic focusing. Using theoretical modelling and scaled physical simulations, They discovered that when the pyramid is exposed to radio waves between 200 and 600 meters in wavelength, it concentrates electromagnetic energy within its internal chambers and directly beneath its base. This effect, they concluded, could make the structure a natural resonator of electromagnetic waves. This does not mean the pyramid was literally a power plant, but it does show that its geometry, its angles, proportions, and internal cavities interact with natural energy fields in complex and measurable ways. The ancient builders may not have used electricity in our modern sense, but they clearly understood resonance, vibration, and harmony, principles that underlie both physics and sound. Acoustic testing inside the Grand Gallery confirms this. Engineers have found that the chamber resonates at 440 Hz. The musical note A, a frequency known as the Earth's natural resonance or Schumann frequency multiple. When tones of this frequency are played, the walls amplify and sustain them. The structure itself seems to hum, as though tuned to the planet's heartbeat. Whether coincidence or design, the effect is real. The pyramid sings. Even the damage inside suggests the building once endured extreme internal forces. The granite beams above the king's chamber are fractured along their length, as if exposed to tremendous pressure or vibration. Scorch marks stain the ceiling of the Grand Gallery in irregular patches, centered where wooden or metal components may once have stood. Egyptologists attribute this to candle soot left by 19th century explorers, but chemical analysis has shown traces of thermal stress, implying far higher temperatures. If the pyramid ever functioned as an energy structure, mechanical, acoustic, or symbolic, something catastrophic may have occurred. Perhaps a structural failure, perhaps a misuse of the system's resonance. Whatever the cause, the monument sealed itself in silence thereafter. For skeptics, all of this can be explained as coincidence, the byproducts of sophisticated but symbolic architecture. Yet even conventional analysis admits mystery. The builders leveled the base to within 21 millimeters across more than 13 acres, a precision unmatched in other ancient constructions. The four sides differ in length by less than 2 inches. The corner angles deviate from perfect right angles by only 12 arc seconds. These tolerances rival those of modern precision engineering. And for what? To house an empty stone box? Alternative interpretations need not claim ancient electricity. The truth may lie somewhere between engineering and spirituality. The pyramid could have been a temple machine, designed not to generate power, but to replicate creation, to resonate with the earth, the stars, and the divine order. In Egyptian thought, energy and divinity were one. To them, power meant Heka, sacred force, the life energy that moves through all things. The Great Pyramid, then, might have been the world's most perfect instrument of Heka, tuned stone amplifying the harmony between heaven and earth. Whatever its purpose, the Great Pyramid's design encodes principles we are only beginning to rediscover. It is both architecture and equation, monument and mechanism. Modern scientists study its symmetry with the same reverence that ancient priests once prayed beneath it, and through that symmetry, we glimpse a civilization that knew the Earth not as a planet, but as a resonant body, alive, musical, and connected to the stars. Even if the Great Pyramid never produced light or energy in a literal sense, it continues to do so metaphorically, illuminating what human ingenuity can achieve when guided by cosmic precision. The story of Giza does not exist in isolation. Across continents, separated by oceans and ages, stand other monuments that whisper in the same architectural language. Immense stones arranged with impossible precision, aligned to the stars, and weathered by time yet defiant of it. It is as if different civilizations, with no recorded contact, had inherited the same design principles from a forgotten teacher. The pyramids of Egypt, as extraordinary as they are, might only be one verse in a global poem written in stone, We begin in southeastern Turkey, where the limestone ridges of the Gürmuş Mountains conceal the oldest temple complex ever discovered, Göbekli Tepe. Unearthed in the mid-1990s by archaeologist Klaus Schmidt, this site dates to at least 9,500 BCE, according to calibrated radiocarbon dating, older than Stonehenge by 6,000 years, and older than any known agricultural settlement. Here, T-shaped pillars up to 5 meters tall, weighing between 10 and 20 tons, form circular enclosures carefully oriented toward the cardinal directions. The stones are covered in relief carvings of foxes, cranes, lions, and serpents. Imagery that seems symbolic, not decorative. What makes Göbekli Tepe so confounding is that its builders were supposed to be hunter-gatherers. There is no evidence of farming, metallurgy, or writing, yet they quarried, transported, and erected megaliths with accuracy that suggests knowledge of geometry and celestial observation. On the most famous slab, the Vulture Stone Pillar 43, a series of animals and astronomical symbols have been interpreted by researchers from the University of Edinburgh as a star map depicting the constellations visible around 10,250 BCE, the same date as the Younger Dryas impact layer found in North American sediments. If that interpretation is correct, Göbekli Tepe may not just mark a sacred place, it could be a memorial to a catastrophe that reshaped the world. Moving westward, we encounter another enigma, the Temple of Jupiter at Baalbek in Lebanon. The visible ruins, constructed during the Roman era, stand atop a foundation of stones so massive that they defy conventional explanation. Each of the trilithon blocks in the lower platform measures about 19 meters long and weighs approximately 800 tons. Nearby lies the Stone of the Pregnant Woman, an unfinished monolith weighing an estimated 1,000 tons, the largest ever quarried by human hands. Modern cranes, even with counterweights, struggle to lift stones half that size. The Romans, whose engineering skill was formidable, left no record explaining how or why they used such enormous blocks when smaller ones would have sufficed. Moreover, the trilithon's construction technique, megaliths cut to interlock with hairline precision, does not match standard Roman masonry, which relied on smaller, mortared stones. Archaeologists now suspect that the Roman builders may have inherited an older foundation, built by a local or unknown culture thousands of years earlier. The sheer mass of the stones resembles those of Giza's lower courses, suggesting a shared tradition of earthquake-proof monumental design. Far to the east, beneath the waves of the East China Sea, lies another mystery, the Yonaguni Monument off the coast of Japan. Discovered by diver Kihachiro Aratake in 1986, this submerged complex features step-like terraces, platforms, and sharp right angles that descend nearly 25 meters underwater. Some scientists, including Japanese geologist Masaki Kimura, believe the formations are the remnants of an ancient city that sank after sea levels rose following the last ice age, roughly 10,000 to 12,000 years ago. Others argue it is a natural sandstone formation, eroded by tectonic uplift and wave action. Yet sonar scans reveal symmetrical staircases, corridors, and even a structure resembling an amphitheatre. Whether natural or modified, Yonaguni lies precisely within the time window of global flooding that followed the Younger Dryas, when melting glaciers raised sea levels by more than 100 meters, submerging coastal plains around the world. Across the Pacific, in the Andes of Peru, the megalithic fortress of Sacsayhuaman displays stonework so tight that no blade of metal can fit between its joints. Blocks weighing over 100 tons interlock in complex polygonal patterns, cut with perfect curvature to absorb seismic shock, a technique unmatched even by modern masons. Similar methods appear in Ollantaytambo and Machu Picchu, where terraces and temples align precisely with solstice sunrises. Some of these megaliths contain magnetized patches, as if the stone was shaped using unknown techniques involving localized heating or vibration. The Inca, when questioned by early Spanish chroniclers, denied having built them. They said the structures were the work of the Viracocha, gods who came before the Inca, a race of tall, wise beings who rebuilt civilization after a great flood. In the Mediterranean, off the coast of Malta, the Gantija temples and Menastra complex also display sophisticated astronomical alignments. Their entrances face the rising sun on the equinoxes, and the stones, some over 50 tons, are arranged in elliptical plans resembling wombs or cosmic portals. Like Göbekli Tepe, these sites predate writing and metallurgy, yet exhibit precise stone engineering and ritual symbolism centered on the heavens. Each of these sites seems to express the same human obsession, permanence, orientation, and the act of remembering. Monumentality becomes the medium of memory. Whether in limestone, basalt, or granite, ancient builders everywhere anchored their faith in geometry and the cosmos. Is this parallel evolution, different cultures independently discovering the same methods? Or are these echoes, survivors of an earlier civilization scattering their knowledge across the world after catastrophe? Modern archaeologists favor the first explanation, citing convergent development, that humans, given similar materials and motivations, will produce similar outcomes. But the coincidences go beyond practicality. The megalithic age, from 10,000 to 3000 BCE, produced not just similar architecture, but similar cosmologies. Across continents, myths tell of divine architects, celestial visitors, or survivors of a deluge who taught the arts of agriculture, measurement, and stonework. In Sumer, the 7 sages, or Apkallu, emerge from the sea after the flood to rebuild cities. In Mesoamerica, Quetzalcoatl and Viracocha do the same. In Egypt, the gods of Zep Tepi descend from the sky to raise the first temples. These are not random stories. They are reflections of the same motif, knowledge descending after destruction. Scientific evidence also hints at ancient global disruption. Around the world, geologists have identified a narrow black layer, the Younger Dryas boundary layer, rich in iridium, soot, and nanodiamonds, marking a sudden planetary event about 12,900 years ago. The coincidence between this date and the emergence of the earliest monumental sites is striking. It suggests not a linear rise of civilization, but a recovery, the resurgence of memory after extinction. If the Great Pyramid is indeed part of this pattern, it may represent not the beginning of architecture, but its preservation, a perfected expression of an inherited science. The precision of Giza, the astronomical alignments of Göbekli Tepe, the Cyclopean masonry of Baalbek, and the submergence of Yonaguni all seem to point toward the same conclusion, that a forgotten lineage of builders once circled the globe, driven by the same impulse, to anchor humanity's story in stone before the world changed again. Perhaps they knew what we are only beginning to remember, that history is not a straight line, but a heartbeat, a rhythm of rise and collapse. The megaliths that dot our planet are the echoes of that rhythm, still pulsing faintly beneath layers of time and myth. Before the desert, there was water. Long before the wind sculpted dunes and the horizon turned to gold, North Africa was alive, a sprawling mosaic of savannas, lakes, and winding rivers. The landscape we call Sahara was once a pulse of green, humming with the rhythm of monsoons and the voices of people who thrived there. To imagine this is to unlearn everything we think we know about the desert. Satellite radar from NASA's Shuttle Radar Topography mission has revealed immense hidden river systems beneath the sand, the fossil veins of a long-vanished ecosystem. One of these, the Tamanrasset River, once flowed for hundreds of kilometers from the Hoggar Mountains of Algeria to the Atlantic Ocean. Its basin was the size of Western Europe. Another, the recently discovered Ahramat branch, ran near the western edge of the Nile and may have been active during the early Holocene, passing directly beside the Giza Plateau. In Arabic, Ahramat means pyramids. That lost river may have been the ancient artery that once fed the very civilization we now call Egypt. Core samples from across the region tell a consistent story. Beneath the dunes lie layers of lacustrine sediment, the remains of ancient lakes, rich with pollen, diatoms, and freshwater mollusks. In the Fayum Depression, sediments reveal alternating bands of clay and sand corresponding to wet and dry cycles. In the heart of the Sahara, at Lake Megachad, scientists have found shorelines showing that, 7,000 years ago, it was one of the largest freshwater lakes on Earth, 400,000 square kilometres, dwarfing today's Lake Superior. Its slow evaporation over millennia mirrors the retreat of the monsoon itself. This lush epoch, known as the African Humid Period, began around 14,800 years ago and ended near 5,500 years ago. The cause was astronomical, a tilt in Earth's axis and a subtle shift in the precession cycle that intensified the African monsoon. Warm air from the tropics pushed farther north, carrying moisture deep into the continent. Rain fell where now there is silence. Rivers carved through sandstone plateaus, grasslands expanded, and people followed the water. Evidence of their lives is everywhere if you know where to look. In the Tassili Naja of southern Algeria, cave walls still glow with ochre images of giraffes, elephants, and hippos, species that cannot survive there now. Some scenes show hunters paddling boats across wide lakes, suggesting not fantasy but memory. Similar engravings appear at the Gilf Kebir Plateau in Egypt, including the haunting Cave of the Swimmers, discovered by Hungarian explorer Laszlo Almasi in 1933. The painted human figures, arms outstretched, seem to float across an ochre sea, a record of real people living in a vanished world of water. Archaeological digs across the Western Desert reveal stone tools, hearths, and animal bones dating back more than 10,000 years. Many of these sites, such as Nabta Playa, near the Sudanese border, were once seasonal lakeside settlements. There, archaeologists uncovered the oldest known astronomical stone circle on Earth, built between 6,000 and 7,000 BCE. The megaliths align precisely with the summer solstice sunrise and the rising of the star Sirius, the same celestial body later revered by dynastic Egyptians as the herald of the Nile's flood. These discoveries suggest a deep continuity, an unbroken thread linking the astronomer builders of the pre-Sahara wetlands with the architects of Giza. When the climate began to dry around 6000 BCE, the people of Nabta Playa and nearby regions migrated eastward, drawn toward the only reliable source of water left, the Nile. They carried their traditions, sky-watching, stone construction, and a reverence for cycles of death and renewal, into the valley that would become the heart of Egypt. If the roots of Egypt truly lie in the lost rivers of the Sahara, what does that make the pyramids? The beginning of civilization, or its memory? Tell us what you think below. And don't forget to like if you'd have loved to see the Sahara when it was still green. Geological and genetic evidence both support this migration. Fossilized pollen from the Nile Delta shows a dramatic shift around 5,500 years ago from aquatic to arid species, marking the final desiccation of the Sahara. Meanwhile, modern DNA studies on ancient Egyptian remains reveal genetic admixture from sub-Saharan populations during the same time frame, consistent with waves of migration from the west. In other words, the desert's collapse didn't just shape landscapes, it shaped the people who would later build the pyramids. The Nile itself bears the scars of these transitions. During wetter millennia, it was not a single river, but a complex braided network of channels and floodplains. Today's narrow valley was once a vast delta of tributaries. Sediment cores taken near Cairo and Giza show alternating bands of clay and sand corresponding to ancient floods. Within these layers, scientists have identified freshwater diatoms, microscopic algae, suggesting that shallow ponds and marshlands once covered the plateau's base. To the builders of Giza, this would have been a world of abundance, where the desert met green fields and limestone quarries stood near navigable water. In that environment, the Sphinx's enclosure would have collected runoff from frequent rains. The deep vertical grooves in its walls are consistent with precipitation-driven erosion, not the arid weathering of later millennia. The Sphinx thus becomes a geological witness, proof that the land which now sees barely an inch of rain per year once endured torrential downpours. Modern climate models reproduce this transformation in startling detail. Using ice core and orbital data, scientists have simulated how the African humid period waxed and waned with precessional cycles. Every 21,000 years, the Earth's wobble nudges the monsoon northward, greening the Sahara. When the wobble reverses, the rains withdraw. The cycle is slow but absolute. We happen to live in one of its driest phases. The last great greening ended only 5,000 years ago, around the same time that Egypt's dynastic civilization rose. Imagine the cultural memory this left behind. Grandparents who remembered rivers where their grandchildren saw only sand. Myths of floods, divine wrath, and rebirth may have sprung from this trauma. The Egyptian story of Atum rising from the watery chaos of Nun to form the first land mirrors the physical reality of their environment, the Nile emerging as the last surviving waterway from a drowned world. This shifting landscape also explains why ancient Egyptians called their country Kemet, the Black Land, named for the fertile soil left by annual floods. Surrounding it was Deshret, the Red Land, symbol of chaos. The contrast between green and desert was not metaphorical, it was existential. They lived on the boundary between worlds, one vanishing, one reborn. In the quiet of the desert today, scientists still hear the echoes of that transformation. Radar images show river deltas frozen under sand, dry basins that once shimmered like mirrors. The very dust of the Sahara, which now drifts across the Atlantic to fertilize the Amazon rainforest, was once fertile topsoil itself. Even in death, the desert continues to give life elsewhere. So when we look at the pyramids today, we may be seeing not the triumph of man over nature, but the memory of a climate's mercy. The builders of Giza, or their forgotten predecessors, may have chosen this plateau precisely because it stood above the floodwaters, stable through cycles of wet and dry. They anchored their monuments on bedrock that had survived countless transformations, perhaps believing the stone itself held the rhythm of the earth. And one day, when earth tilts again and the monsoon returns, the rivers will wake, the dunes will bloom, and the ancient waterways that once reflected the pyramids may flow again, completing the cycle that began long before history in the green Sahara, where civilization first learned to look up at the stars and carve its dreams into stone. It began with light, not the soft light of dawn, but a searing brilliance that split the heavens. For the people of that ancient world, it must have seemed as though the gods themselves had struck the sky. Around 12,900 years ago, the Earth entered one of its most violent and mysterious transitions, the event now known as the Younger Dryas cataclysm, when global temperatures plunged, rains stopped, and the age of green turned suddenly to ice. For nearly a century, scientists believed this sudden freeze was caused by meltwater from retreating glaciers flooding the North Atlantic, disrupting ocean currents. But beginning in the early 2000s, new evidence emerged that pointed to something far more explosive. Beneath a thin black layer of soil, the so-called Younger Dryas boundary layer, geologists across North America, Europe, and the Middle East found the unmistakable chemical fingerprints of catastrophe. Nanodiamonds, melted glass spherules, magnetic microspherules, and spikes of iridium and platinum, elements rare on Earth but common in asteroids and comets. In Greenland's ice cores, These same elements mark a precise horizon of destruction. The data point to an impact or airburst event, perhaps a fragmented comet, that struck or exploded above the northern hemisphere around 12,900 years ago. This would have unleashed shockwaves, heat pulses, and wildfires on an unimaginable scale. The theory, known as the Younger Dryas impact hypothesis, was first proposed by physicist Richard Firestone and later supported by teams at the University of Kansas and UC Santa Barbara, who identified widespread carbon-rich black mats formed by massive burning of vegetation. Imagine what that meant on the ground. The sky ignites, the forests burn for months, the air itself turns to ash. Across North America, an estimated 10 million square kilometers of land caught fire, an inferno that blotted out sunlight. Radiocarbon records show a sudden global increase in ammonia and nitrate aerosols, consistent with biomass combustion. In seconds, temperatures rose above 2,000 degrees Celsius in some regions, melting rock into glass. Then came darkness. The soot blocked the sun, triggering rapid cooling. Within decades, or perhaps only years, average global temperatures dropped by 5 to 8 degrees, thrusting the planet back into near-glacial conditions. This wasn't just a northern disaster. Evidence of the same boundary layer has been found in the Middle East, Syria, and even along the Nile Delta. Egyptian sediment cores show a surge in charcoal and soot deposits dating to that exact period. In Syria's Abu Huraira, one of the world's oldest known villages, microscopic glass beads called impact spherules are embedded in burned grain and bone fragments, the aftermath of a firestorm so intense it carbonized everything in moments. If such devastation reached North Africa, it would have annihilated the lush ecosystems of the Green Sahara. The monsoon rains would have faltered, lakes dried, rivers disappeared, and plant life collapsed. To the survivors, it must have seemed like divine punishment. The myths that later emerged, of floods, fiery destruction, and angry gods, could all be memories of that night when the heavens fell. Every culture seems to remember it. In Egypt, the Eye of Ra, the fiery disk sent by the sun god to punish humanity, scours the earth until Ra repents and draws it back. In Mesopotamia, Enlil destroys the cities of men with storms and fire. The Greeks told of Phaethon, who seized the sun chariot and scorched the world before being struck down by Zeus. The Hopi speak of a previous world destroyed by a great fire from the sky. The Chinese record a celestial dragon whose fall turned the heavens red. All these tales differ in language but echo the same catastrophe, the sky that burned. Modern data align hauntingly with myth. In Carolina Bays, thousands of elliptical depressions dot the US East Coast, thought by some geologists to be the scars of high-velocity ice and debris impacts from an airburst. In Canada, craters such as Charlevoix and Mistastan show impact ages clustering near the Younger Dryas onset. Meanwhile, the sudden extinction of megafauna, mammoths, mastodons, giant sloths, and saber-toothed cats coincides perfectly with this boundary. Genetic evidence shows a massive population bottleneck among large mammals around 12,900 years ago, and archaeological data reveal that the Clovis culture of North America vanished almost overnight. What does this mean for human civilization? For most of the world, it was an erasure, a reset. Populations collapsed, migration patterns shifted, and thousands of years of fragile development were lost. But some survived. Along rivers, coastlines, and mountain shelters, small groups endured the cold centuries that followed. They carried fragments of memory, not just myths, but techniques, stone cutting, navigation by stars, measurement of time through celestial cycles. When the planet warmed again around 11,700 years ago, those survivors began to rebuild. In Turkey, just after the Younger Dryas ended, Göbekli Tepe rose from the dust. its circular temples decorated with carvings of vultures and burning suns, as if memorializing the disaster that came before. In Mesopotamia, early flood myths appear in the Eridu Genesis and later in the Epic of Gilgamesh, describing a deluge that wiped away earlier ages. In Egypt, priestly texts later spoke of Zep Tepi, the first time when the gods restored order after chaos. Geological evidence shows that as the Younger Dryas ended, the world changed again, this time through rising seas. Meltwater from collapsing ice sheets poured into the oceans, raising global sea levels by up to 120 meters over the next several millennia. Entire continental shelves, including those off Egypt's Mediterranean coast, were submerged. If coastal settlements had existed before, they now lay buried beneath hundreds of feet of water, waiting for rediscovery. A few traces may already have surfaced. In 2000, sonar mapping off the Indian coast near Dwarka revealed submerged walls and grid-like structures at depths of 30 meters. In the Caribbean, divers near Cuba's Guanahacabibe's peninsula reported pyramid-like formations on the seafloor, although these remain unverified. Closer to Egypt, the drowned cities of Heraklion and Canopus, only 2,000 years old, remind us how easily entire civilizations can vanish under rising seas. How many older cities still sleep beneath deeper waters? If the builders of the Giza Plateau had ancestors in that pre-cataclysmic world, perhaps they were among the few who survived, guardians of knowledge passed through catastrophe. Their monuments might then be not beginnings, but memorials, records in stone of a civilization that once faced the wrath of the heavens and endured. Scientific caution urges skepticism. No definitive impact crater has been tied to the Younger Dryas, and debates continue. But as evidence accumulates, in spherules, soot, isotopic anomalies, and myths, a pattern emerges that is impossible to dismiss entirely. Something extraordinary happened around 12,900 years ago, something that left both geological scars and cultural memories across the globe. The Pyramids of Giza, if they truly preserve remnants of that forgotten epoch, may therefore stand as survivors of two worlds, one before and one after the fire. Their silence could be the silence of witness, because when the sky fell, the earth changed, the rains ceased, the rivers died, and yet, against all odds, memory endured. In the stars, in myth, and in the stones that still gleam faintly beneath the Egyptian sun. If a civilization capable of shaping the Giza Plateau existed before the Younger Dryas, where did it go? Where are its bones, its tools, its cities? The Great Pyramid and Sphinx stand as if dropped into history from nowhere, architectural perfection emerging fully formed. For archaeologists, this silence is proof that no such civilization existed. Yet silence in the desert is deceptive. It does not mean absence, it means erasure. Stone remembers what flesh cannot. Human remains decay far faster than the monuments they raise. Even in the hyper-arid climate of Egypt, bone, wood, and textiles vanish within centuries, unless perfectly sealed from air and moisture. Most of Egypt's early human settlements, mud brick villages along the Nile, were destroyed by the very river that sustained them. Each annual flood eroded the banks, burying one layer of life under another. Over 12,000 years, those floods laid down tens of meters of silt, swallowing entire landscapes. If an earlier civilization lived and died here, it would now lie far below the modern floodplain, sealed beneath the fertile earth that later dynasties farmed. Geologists estimate that the Nile Delta accumulates sediment at an average rate of 1 millimeter per year, a slow-motion burial of time. In 10,000 years, that's 10 meters of new ground. Modern Cairo sits atop layers of forgotten settlements, each era built upon the ruins of another. Beneath the bustling modern city, ground-penetrating radar has detected outlines of older walls and foundations. Yet excavating them is impossible without dismantling the city itself. The same is true along the Mediterranean coast. When sea levels rose after the Younger Dryas, the shoreline advanced inland by nearly 100 kilometers, drowning whatever evidence may have existed of pre-dynastic ports or coastal cities. Underwater archaeology has already revealed how fragile history can be. The submerged cities of Heracleion and Canopus, lost just 2,000 years ago, were discovered in 2000 beneath 30 feet of water and several meters of sediment. Entire temples, statues, and docks lay preserved in darkness, invisible until sonar detected them. If whole cities of Egypt's classical age could vanish so easily, what chance did older civilizations, erased by floods 10,000 years earlier, have of survival? And yet hints remain. Scattered across the Nile Valley are out-of-place artifacts and enigmatic structures that don't fit neatly into the known timeline. The Osirion at Abydos, a subterranean temple attributed to Seti I, was built with granite blocks weighing up to 100 tons, arranged in a style older than the pharaoh's own temple above it. Archaeologist Margaret Murray noted in 1904 that its construction bears the appearance of a building belonging to a far earlier epoch. Similarly, the Valley Temple of Khafre near the Sphinx is made of gigantic limestone blocks weighing as much as 400 tons, quarried and fitted with millimeter precision. The casing of the adjacent Sphinx temple shows erosional patterns deeper than those on the Sphinx itself, suggesting that it may predate even that monument. If these megalithic foundations were remnants of an earlier phase of civilization, later Egyptians might have simply rebuilt upon them, repurposing their stones without fully understanding their origins. This pattern of cultural inheritance and reinterpretation appears throughout history. The Romans built temples atop Etruscan ruins. The Spanish erected cathedrals over Mayan pyramids. Each generation reuses the bones of the one before, until only the stone remains, stripped of memory but not of purpose. Even the oldest written records of Egypt echo this theme of inheritance. The pyramid texts of the Old Kingdom, carved more than 4,000 years ago, refer to the followers of Horus, semi-divine beings who ruled Egypt before the pharaohs. They mention sacred mounds of the primeval land, where the gods first established order after chaos, an image that mirrors the geological rise of dry land after the Great Floods. Later inscriptions, such as the Turin King list, contain whole columns of names labelled simply Shemsu-Hor, their reigns stretching back thousands of years beyond any recognised dynasty. Mainstream historians interpret these as myth, but perhaps myth is how the memory of lost history survives. Even physical anthropology leaves room for the unknown. Excavations in the Western Desert at sites like Bir Sahara East and Nabta Playa have uncovered human remains dated between 8,000 and 10,000 years old, people who lived long before the first pharaohs. Their skeletal proportions differ from later Nile Valley populations, suggesting a mixed origin of northern and sub-Saharan lineages. If they were the descendants of survivors from an even older culture, one displaced by the Younger Dryas catastrophe, their DNA might carry the faint echoes of that vanished world. Modern genetic studies are beginning to detect these patterns, deep ancestral lineages in North Africa that split from other populations 30,000 years ago but re-emerged in the early Holocene, precisely when the Sahara turned green again. And what of the tools, the workshops, the dwellings? Stone survives, but clay and reed do not. The Nile's seasonal floods would have dissolved every trace of such materials. Even copper, the earliest known metal, corrodes completely after millennia in wet silt. The further back we look, the less likely we are to find tangible artifacts, especially from a civilization that may have built in perishable materials, reserving stone only for sacred monuments meant to last forever. This pattern of selective preservation distorts our understanding of prehistory. Archaeologists reconstruct the past from what remains, but what remains is rarely representative. The durable survives, the delicate does not. Thus, the absence of pottery or writing before 4000 BCE may reflect not ignorance, but impermanence. The people who carved the Sphinx or aligned the pyramids might have left behind a rich culture now lost to climate, flood, and time. The silence of the builders is therefore not emptiness but compression. Knowledge folded into myth, memory fossilized into architecture. The Egyptians themselves seem to sense this. They spoke of Zep Tepi, the first time, as a golden age that ended before written history, when the gods walked the earth and built the first temples. Later kings didn't claim to surpass that age, they sought to restore it. The Great Pyramid itself, if it inherited the foundation of an older monument, may have been an act of restoration, a bridge between the world that fell and the one reborn. For scientists, this is still conjecture, but the physical record continues to tease. Ground-penetrating radar and muon tomography have detected voids beneath and inside the Great Pyramid, sealed chambers whose purpose remains unknown. The desert, it seems, still guards its final testimony. The builders' bones may have crumbled, their language may be gone, but the precision of their work defies the passage of time. The limestone blocks that line the Sphinx temple still fit so tightly that a human hair cannot pass between them. Such craftsmanship is itself a kind of speech, the grammar of geometry, the syntax of stone. Perhaps that is the true legacy of the Silent Ones. They did not need to write their names because their work would speak across millennia. The pyramids and temples are their alphabet, the alignments and proportions, their message. And though we have yet to translate it fully, one phrase already stands clear. We were here. We endured. From above, Egypt appears eternal, a narrow ribbon of green cutting through an endless gold sea. Yet what we call known history is only a thin layer of this landscape's memory. Beneath the sands lie thousands of years of unexcavated time, stacked like pages sealed by dust. For every tomb, temple, and city uncovered, hundreds remain hidden. The desert is not empty, it is unread. Modern archaeology often speaks with certainty. Dynasties dated, kings listed, timelines drawn. But when satellite imagery is compared with excavation records, the illusion of completeness vanishes. Less than 2% of Egypt's landmass has ever been systematically explored. The rest, millions of square kilometers, is blank on the archaeological map. The Nile Valley is one of the most densely studied places on Earth, and even there, countless ruins lie beneath farmland, asphalt, or meters of silt deposited by annual floods. Every time the Nile overflowed, it erased and rewrote the ground beneath. The Nile Delta, today a web of canals and rice fields, was once a labyrinth of shifting river mouths. Geologists using seismic reflection surveys have traced ancient channels buried more than 10 meters below the surface, now invisible to the eye. Some of these, like the recently rediscovered Ahramat branch, ran directly past the Giza plateau. When sea levels rose after the last ice age, much of this region flooded. The ancient coastline lay as far as 100 kilometers north of its modern position. Any settlement that existed there, ports, quarries, or early towns, is now deep underwater, entombed beneath layers of clay. The silence of this buried world began to lift only with the invention of new eyes. In the last 2 decades, remote sensing archaeology has transformed how we see Egypt. From orbit, satellites detect minute differences in soil composition, moisture, and temperature. These subtle patterns reveal shapes invisible from the ground: buried walls, roads, canals, and even foundations. In 2011, Egyptologist Sarah Parkak used infrared satellite imaging to identify 17 potential pyramids, 1,000 tombs, and 3,000 forgotten settlements. Later ground surveys confirmed several of them. Her discovery earned her the nickname Space Archaeologist, and it reminded the world that the desert is not barren, it is a living archive. Other technologies have peeled back more layers. LiDAR, a laser-based mapping system, can penetrate sand drifts to reconstruct the contours of what lies beneath. While it revolutionized Maya studies in Central America, it is now being tested across Egypt's oases and wadis. Preliminary scans have already revealed geometric anomalies near Baharia and Siwa, rectangular outlines suggesting walls or enclosures buried under dunes. These shapes, perfectly aligned to cardinal directions, may represent ancient settlements lost during the desertification that followed the end of the African humid period. At Saqqara, ground-penetrating radar has revealed entire necropolises before excavation, corridors, workshops, and staircases leading to unknown tombs. In 2020, archaeologists uncovered the City of the Dead, a vast complex of sealed coffins dating from the late period. Yet the ground-penetrating radar scans also showed deeper anomalies, older chambers that remain untouched. Egypt, even in its best-studied zones, hides civilizations beneath civilizations. Perhaps the most astonishing window into the unseen came in 2017, when scientists from Nagoya University and the Hippie Institute in France used muon tomography, a particle imaging method similar to X-rays, to peer inside the Great Pyramid itself. They discovered a previously unknown void above the Grand Gallery, roughly 30 meters long and several meters high. Its exact purpose remains uncertain: structural relief chamber or hidden hall. Either way, the revelation shocked the scientific world. If such a space can remain undiscovered inside the most studied monument on Earth, how much more might be waiting beneath the sands that stretch for thousands of kilometers beyond? The Western Desert alone covers 2/3 of Egypt's territory. Beneath its dunes lie paleo lakes, ancient trade routes, and perhaps forgotten temples built when the Sahara was still green. In 2015, radar surveys in the Gif Kabir Plateau revealed a network of buried riverbeds converging on what may have been once a thriving settlement near Gebel Uvaynat, now an empty wilderness. Excavations there have found pottery shards and tools dating to 9,000 years ago, but the sand continues to reclaim every discovery as soon as it is exposed. In the desert's language, time is erosion. To the north, along the Mediterranean shelf, underwater sonar has begun tracing drowned coastlines. Off the modern port of Alexandria, the remains of Heraklion and Canopus were rediscovered in the 2000s by French marine archaeologist Frank Godiot. Their temples, statues and docks lie preserved in perfect detail beneath 10 meters of water. These cities are only 2,000 years old. Proof that even in recorded history, Egypt can lose entire metropolises to the sea. Extend the timeline back 10,000 years and the scale of loss becomes unimaginable. If ancient Egypt inherited its knowledge from a civilization that flourished before the Younger Dryas, much of that evidence might lie beyond reach, under layers of silt or hundreds of feet below the Mediterranean. Even our instruments, advanced as they are, scan only shallow depths. Oceanographers from the European Space Agency estimate that less than 20% of the world's seafloor has been mapped with high-resolution sonar. The rest, like the desert, is blind terrain. Yet blindness is not permanent. Every year, new technologies sharpen our vision. Satellite gravimetry measures minute variations in Earth's density, revealing buried structures. Hyperspectral imaging detects minerals that form only near human settlements. Artificial intelligence is now being trained to identify archaeological anomalies from satellite data, learning to recognize the subtle geometry of civilization even when half buried in sand. Still, the paradox remains. Even as we see more, the known world grows stranger. Each discovery expands not closure, but mystery. The more we learn about what lies beneath Egypt's surface, the clearer it becomes that our picture of its past is fragmentary, a single visible thread in a vast hidden tapestry. In 2022, the Egyptian Geological Survey began collaborating with NASA scientists to map ancient river systems across the Sahara using radar interferometry. Their data reveal what appears to be a subterranean Nile tributary running parallel to the modern river, buried beneath hundreds of meters of sediment. This ghost river, perhaps once navigable, could explain why the earlier settlements formed where they did, and why monumental sites like Giza occupy precisely those elevated ridges between vanished waterways. It's humbling to realize that the land we think we know has only been lightly touched by archaeology. Beneath the dunes may lie not just tombs, but entire lost eras, pre-dynastic cultures whose names we will never read. The silence of the sand is not an absence of history, but its overabundance, compressed and concealed. If the Great Pyramid stands as the apex of visible Egypt, then the invisible Egypt, the one hidden below, drowned or eroded, might be infinitely greater. The true story of this land may not be what we see above ground, but what remains beneath it, waiting for the right moment, the right technology, or perhaps the right question to awaken it. And that is the great irony. We search the sky for answers about our origins, yet beneath our feet lies an entire uncharted world, the blind spot of human history, quietly breathing under the sand. Long before the first hieroglyph was carved, before the names of Khufu or Ramses echoed through the halls of stone, Egypt's priests whispered of an age so distant that it existed outside history. They called it Zep-Tepi, the first time. To them it was not myth but memory, the beginning of civilization itself, when divine beings ruled Egypt, raised temples, and restored order to a world that had drowned in chaos. In temple inscriptions from Heliopolis, the city of the sun, Zep-Tepi was the moment when the god Atum emerged from the dark waters of Nun, standing upon the Ben stone, the first mound of creation. From that mound, the gods of air, moisture, and light were born. To the theologians of the Old Kingdom, this was both a cosmological and geological event, the re-emergence of land from flood. But to the historian or geologist reading between the lines, it may echo a real episode. The rebirth of civilization after the cataclysmic floods that followed the Younger Dryas, roughly 11,700 years ago. The Egyptians understood time as cyclical, not linear. Their word for eternity, neheh, meant perpetual recurrence, the same moment repeating through ages. Thus, Zep-Tepi was not only the first time, it was every time the world was renewed after destruction. In their worldview, creation and memory were inseparable. Every sunrise reenacted Atum's first rising, every inundation of the Nile repeated the first emergence of land. What makes this cosmology remarkable is how it mirrors the natural cycles revealed by modern geology. Paleoclimatologists describe the abrupt warming at the end of the Younger Dryas as one of the most dramatic environmental shifts in prehistory. Rapid ice melt, rising sea levels, and torrential rainfall across North Africa. For ancient peoples living along the Nile, the world truly would have seemed reborn from water. Their creation myth, then, is not a fantasy, but a poetic fossil of experience. The Ben stone, housed once in the great sun temple of Heliopolis, may have been a symbolic model of this rebirth. Shaped like a miniature pyramidion, a gleaming capstone covered in electrum, it embodied both the rising sun and the emergence of solid ground. Archaeologists see it as the prototype of all later pyramids. The very name Pyramidion derives from Peramusir, the house of Osiris's ascension. In this sense, the Great Pyramid could be interpreted as a gigantic Ben, a recreation of the first mound, a monument to rebirth after the deluge. Ancient texts support this connection. The pyramid texts inscribed in the tomb of Pharaoh Unas describe the king's ascent to the stars, to stand on the first mound which emerged from the waters. The king becomes one with Atum, participating in the original creation. The physical pyramid, perfectly aligned with the stars of Orion and Sirius, thus becomes a ritualized cosmos, a technological symbol of the first time engineered in limestone and granite. At Heliopolis, priests developed a theology called the Ennead, the 9 creator gods, each representing a stage of cosmic order arising from chaos. The same pattern of 9 recurs in Sumerian and early Vedic myths, suggesting that the idea of divine architects spreading order may have older, pre-flood roots. Comparative mythology finds striking parallels. In Sumer, Enki raises the land from the abyss. In Hindu cosmology, Vishnu rests upon the cosmic ocean before birthing the new world. In the Hebrew Genesis, the Spirit of God moved upon the face of the waters. Whether coincidence or inheritance, the symbolism points to a shared memory of a world restored from flood. The inventory stele, discovered near the Sphinx in the 19th century and often dismissed as late fiction, deepens this riddle. It describes Pharaoh Khufu visiting the site of the Sphinx and the house of Isis, which already stood in ruin. He is said to have restored the monument, not built it. Egyptologists call this anachronistic, yet its narrative matches geological evidence of water erosion on the Sphinx enclosure, damage far older than Khufu's reign. If the stele preserves even a kernel of truth, it means the pharaohs saw themselves as restorers of something sacred and ancient, the physical legacy of Zep-Tepi. To the priests, this continuity was everything. The rituals of the New Year festival at Heliopolis reenacted the first time. Each sunrise, they poured water over the Benben stone, symbolizing the receding flood, while chanting hymns that called upon Atum to rise again upon his mound. This was not mere religion. It was remembrance disguised as worship, a code through which the memory of environmental cataclysm and renewal survived across millennia. Modern archaeology provides a haunting parallel. Around 11,000 years ago, exactly when the Younger Dryas ended, human activity along the Nile abruptly increased. Sites like Wadi Kubaniya and Nabta Playa show evidence of planned settlements, astronomical observation, and early domestication of cattle. Genetic studies indicate that these early Nile populations mixed with groups migrating from the drying Sahara, climate refugees carrying memories of lost lakes and rivers. Within a few millennia, they would become the people who built Egypt's first temples. Could the myth of Zep-Tepi be the echo of this convergence? The moment when survivors of a vanished world gathered along the reborn Nile and began again. Some Egyptologists, like R.A. Schwaller de Lubitsch and John Anthony West, have argued that Zep-Tepi encodes advanced scientific understanding, celestial precession, harmonic geometry, and the mathematics of Earth's cycles. While their claims remain controversial, new findings lend subtle support. The axis of the Great Pyramid's descending passage points to the star Thuban, the pole star around 2500 BCE, but also aligns with the celestial pole as it would have appeared around 10,500 BCE, the epoch repeatedly marked in Giza's stellar correlations. Whether intentional or inherited, such alignments reinforce the idea that the builders were referencing a much older sky, and perhaps that was the purpose of Zep-Tepi as both myth and monument, to preserve not just theology but chronology, a timestamp encoded in architecture. A civilization that had endured cataclysm might seek to anchor its rebirth in something eternal, the stars. By aligning their sacred sites to the heavens, they turned their history into a cosmic clock that could outlast memory itself. This theme of divine teachers and restoration appears worldwide. The Sumerians spoke of the Anunnaki, who came after the flood to rebuild cities, the Mayans of Itzamna, who taught writing and astronomy after the waters receded, the Andean legends of Viracocha, who recreated man from stone after the deluge. Egypt's version was gentler, more cyclical. Its gods did not destroy to punish, but to renew. To the priests of Heliopolis, The pharaoh was not a god in his own right, but the vessel of the god's memory. Each coronation was a reenactment of Zep Tepi, each pyramid a recreation of the first mound. The word chem, root of alchemy, meant to blacken, both the fertile soil of the flood and the transformation of base matter into spirit. In their cosmology, rebirth required descent into darkness before rising again, just as the earth itself had done after the Younger Dryas. If this is true, then Zep Tepi is not only mythic, it is geological, astronomical, and historical. It is the collective memory of humanity's first renaissance. Perhaps that is the secret the priests tried to preserve, that creation never truly ended. It only waits, sleeping beneath the sands, until humanity remembers how to awaken it again. Night over Giza feels older than time itself. The crowds are gone, the floodlights fade, and the desert returns to its natural darkness. A silence so deep it seems to absorb thought. The Great Pyramid, now a jagged silhouette against the stars, stands like the Earth's oldest compass, its apex pointing invisibly toward the heavens. When the wind quiets, the air hums with a kind of low vibration. Perhaps the resonance of the planet itself, or perhaps only imagination responding to the magnitude of what endures. The longer you stand there, the more the boundary between sky and stone blurs. Above, the constellations drift slowly westward. Below, their shapes are echoed in geometry. Orion mirrored in the pyramids, the Milky Way mirrored in the Nile. This is not coincidence, it is continuity. For thousands of years, people have come here to gaze upward, sensing that these stones were meant to remind us that we are part of something vast, that our story was written into the stars long before we learned to write it in clay. The question that lingers, however, is not how these monuments were built, but why they still move us. Why do they feel alive, not as ruins, but as witnesses? Modern archaeology can map their dimensions down to the millimetre, yet the deeper mystery remains untouched. The Great Pyramid's base is level to within 21 millimetres across 13 acres. Its sides deviate from true north by only 3 arc minutes, a precision unmatched until the invention of GPS. Its interior passages encode the ratio of the Earth's polar radius to its equatorial circumference, and its height once equaled 1/1000th of that circumference. These coincidences might be mathematical serendipity, or they might reveal a design meant to embed knowledge in stone. Either way, they remind us that we stand before minds that thought not in years, but in cosmic scales. The builders are gone, yet the structure behaves as if it were still alive, resonant, balanced, harmonic. Acoustic experiments conducted by the Institute of Sound and Vibration Research at the University of Southampton in 2003 found that the King's Chamber resonates strongly at frequencies between 117 and 440 Hz, matching the Earth's natural oscillations. When certain tones are played, the granite walls amplify and sustain the sound, as though the pyramid were designed to sing with the planet. Whether intentional or not, this harmony between architecture and physics gives the impression of communication. A message not in words, but in vibration. Standing in the darkness, one realizes that perhaps the Great Pyramid's true purpose was not practical at all. It was existential. It was meant to remind anyone who looked upon it that human life is fleeting, but understanding, the alignment between heaven and earth, can be eternal. When light from distant stars reaches the plateau, it has travelled for millennia. The photons now reflecting off the limestone may have left their suns when mammoths still roamed the plains. To observe Giza under starlight is to see time itself folded. The same light that touched the faces of the builders now falls upon yours. You become part of their story simply by looking. Astronomers note that precession, the slow wobble of Earth's axis, has shifted the heavens since the pyramids were built. Yet when software reconstructs the sky of 10,500 BCE, Orion rises precisely where the pyramids point, and Leo, the constellation of the Sphinx, ascends on the eastern horizon. The monuments, in other words, capture a sky that no longer exists. They are time capsules of celestial alignment, fixed in stone while the Earth drifts. The pyramids have watched the North Star migrate from Thuban to Polaris, the Nile change its course, and civilizations rise and vanish. They have outlived every empire that claimed them. Even the desert itself, shifting, growing, eroding, is younger than these stones. Perhaps that endurance is the answer. The builders may have known that everything else, their languages, cities, even their descendants, would vanish. So they created something immune to forgetting. The Great Pyramid is not a tomb, not even a temple. It is memory crystallized in architecture. It does not tell a story. It is the story. Science approaches Giza through measurement. Religion approaches it through reverence. But in truth, the monument belongs to both. To physicists, it is an impossible machine of symmetry. To mystics, it is a portal to eternity. To archaeologists, it is a puzzle half solved. And to the night sky, it is a mirror, a reflection of the stars that gave it meaning. In recent years, muon tomography, a cosmic ray scanning technique, has revealed hidden voids inside the Great Pyramid, including a vast chamber above the Grand Gallery. No one knows what it contains. Some believe it is structural, others think it conceals the final secret of the monument. But what's striking is that it remained unseen for 4,500 years despite endless study. Even today, under all our technology, the pyramid keeps its silence. It yields just enough to renew curiosity, then retreats again into mystery. That silence, however, is not empty. It hums like the pause between heartbeats, a resonance that links the living and the lost. Every civilization leaves echoes, but Giza still speaks because it was designed to speak through the ages, in a language that never decays: proportion, light, and alignment. Perhaps this was the builder's message: not instructions, not prophecy, but invitation. To look upward, to measure ourselves against the cosmos, and remember that our knowledge, however great, will one day be dust, but our capacity for wonder can be eternal. Astronauts aboard the International Space Station have described seeing the Great Pyramid gleaming faintly under moonlight, a sharp white triangle visible even from orbit. From that vantage point, it appears as it must have to the builder's gods, a perfect meeting point between planet and sky. In that sense, the pyramid is still doing its work, bridging worlds. The desert wind rises again, carrying grains of sand across the plateau. They swirl around the pyramid's base, eroding imperceptibly, a billion tiny acts of forgetting against the defiance of stone. Yet even erosion plays its part. It ensures that the monument is alive, that it changes as the earth changes, that it participates in time rather than merely surviving it. Somewhere deep within, the pyramid's hidden chambers remain sealed. If they contain anything, relics, symbols, or only air, their real treasure is their restraint. Mystery itself is their offering, because as long as we do not know, we will keep searching, and in that search we remember what it means to be human, a creature caught between curiosity and awe. Perhaps that is the final secret of the ancient world, that immortality does not mean living forever, but being remembered whenever someone looks at the sky and wonders who built the first monuments and why. The wind quiets, the stars shimmer, and for a fleeting moment it feels as if time itself holds its breath, the earth listening to its own memory. If the pyramids are truly the echoes of a civilization that survived an ancient cataclysm, then what story were they built to tell? Share your thoughts below. Do you believe they were the tombs of kings, or messages from survivors sent across time to the future? And if you wish to keep exploring the mysteries buried beneath the sands and among the stars, subscribe and join us as we continue opening the doors that still sleep in the dark.